In this video, we will discuss decimal expansion of rational number. Rational number is of the form p by q, where p and q are integers, q is not equal to 0. For example, 3 by 7, minus 2, 5 by 9, minus 8 by 16, 17, and so on. Now look at this, minus 2. Why we call minus 2 as a rational number? Because minus 2 can be written as minus 2 divided by 1. So 1 is the denominator, and that means this is of the form p by q, where q is not equal to 0, q is equal to 1 here. So that's why each and every whole number is a rational number. Now, method to find decimal expansions of rational numbers. 13 divided by 8. So 8 ones are 8. 13 minus 8 is 5. Put 0, so point. Then 8 6 are 48. 50 minus 48 is 2. Then again put 1 0. 8 2s are 16. Then 20 minus 16 is 4. 0. Again put 0. 8 5s are 40. 40 minus 40 is 0. So if we get remainder is 0, then decimal expression of a rational number is always terminating. 13 divided by 8 is 1.625, which is terminating expression. So 13 by 8 is 1.625, which is terminating expression. Now consider the second one, 9 divided by 11. So 9 is less than 11. So we put 0 here, 0 point. Now 11 8s are 88. 90 minus 88 is 2. Then again put 0. 11 1s are 11. 20 minus 11 is 9. Again put 0. So 90. Now you can see 9, and again here is 90. So this will keep repeating. So again 11 8s are 88. 90 minus 88 is what? 2. So look at this. Again this is repeating here. So 20, if you put 0, so 11 ones are 11, and then the remainder is 9. Now remainder is never get 0, because we will get either remainder is 9 or remainder is 2. So that means if the remainder is non-zero, you will get non-terminating but repeating pattern. So 0.818181 and so on. So here 81 is repeating, 8181 is repeating. So we can write these as 0.81 bar. So bar is on 81 only. Be careful about the bar. For example, if you write 0.81 bar, this means it is nothing but 0.81111 and so on. So here 1 is repeating, not 81. So be careful about bar. So this is what, if the remainder is non-zero, you will get non-terminating but recurring pattern, recurring decimal expression. Now consider the negative one, minus 2 by 15. So to find the decimal expression of negative fractions minus 2 by 15, consider the positive 2 by 15 and then find out the decimal expression of 2 by 15. As 2 is less than 15, we put 0 here. 0.15 ones are 15. 20 minus 15 is what? 5. Again put 0 here. So 15 threes are 45. So 50 minus 45 is 5. Now you can see the repetition of 5. So again put 0 here. So again 15 threes are 45 and so on. So the remainder is 5, which is not equal to 0. So you will get for non-terminating but repeating pattern 2 by 15 is 0.1333 and so on. So 3 is repeating. So 0.13 bar. Bar is on 3 only. So that means if the positive 2 by 15 is 0.13 bar, minus 2 by 15 is, just substitute the negative sign, 0.13 bar. So in the decimal expression of a rational number, either you get terminating decimal expression or non-terminating but repeating decimal expression. So for example, 13 by 8 is 1.625. These are the terminal terminating decimal expression, and these are the non-terminal decimal expression. Now, when we get terminal decimal expression and when we get non-terminal decimal expression, so the point is the rational number is of the form p by q, where q is the denominator. If the denominator is of the form 2 raised to n into 5 raised to m, that means what? They are the factors of 2 and 5 only. Then you will get terminating expression. Otherwise, you will get non-terminate expression. For example, in some MCQs, the problem is to find whether the fraction is terminating or non-terminating. Just see the denominator. If the denominator is a factor of 2 and 5 only, then it is terminating. Otherwise, if it contains, say, 2, 5, 3, 7, then it is non-terminating. So see the example, 13 by 8 is 1.625. Why? Because the denominator is 2 cube. Here the denominator is 2 square. 1 by 4 is 0.25. 2 by 9, the denominator is 3 square. They are not factors of 2 and 5 only. So that's why we are getting non-terminating and repeating pattern. So what are the use of decimal expression? So in some of the calculations, decimals are useful. Why? Because the calculations make easy. For example, 5 by 8 plus 1 by 20, you will get quick results if you use the decimals like this. And in financial calculations, decimals are useful. For example, interest rates are in decimals. Computers are decimals. Computer use decimals to perform calculations. So thus, rational numbers is they are of the form p by q, or if the decimal expression is either terminating or non-terminating, recurring numbers are called rational numbers. So if we get non-terminating and non-recurring decimal, then that numbers are called irrational numbers. So there are irrational numbers where decimal expression is non-terminating and non-recurring. For example, this ones pi, root 3 or 1.327859 and so on. So these are the irrational numbers. So I hope you enjoyed the video. Thank you.